Hey everybody, good afternoon. Good to see you guys. We just got a little more time until we start. 2 minutes basically. But for now, welcome back and good to see you. Hi Philip. Hey. Just another minute, guys. Welcome back. Hey Anna, how's it going? Hey Corey, welcome too. Good to see you. All right then, guys. Now that we're pretty well to 2:20, I'm gonna just slowly get things started. Good to see everybody. Hi Oliver, Remy, and all the rest. So yeah, let's just set the table for today's meeting and the next few meetings to come. Right now, by the way, on Tuesday, thank you guys for hopefully watching some of those videos that I sent around. We had a little media lesson over the last two meetings. Last Thursday, we had a lecture-based meeting, and then I wanted to bring in some multimedia, share some videos with you guys. So I just kind of gave them to you in a Canvas announcement for you to watch at your own convenience. Hopefully you've had a chance to see them. They're helpful and they're useful for you as you complete your third homework. Don't forget that third homework is due anytime before midnight on Sunday, so end of the day Sunday. You just got to send me your submission where you have the fallacies and advertisements that you've been able to collect. Now about that, about that assignment, one thing that I think would help anybody who's trying to do it would be to consider looking at like magazines as well as just things that you find online. Because when I used to do this assignment as an in-class group activity, I would just have every student bring a magazine with them and they would get into groups, and working together in groups, they would always be able to find like all 20 fallacies, like literally in just the 85-minute window of class. So I know that it's possible to get them, and especially since you have way more time than just that, you should be able to do it. Sometimes when you search online, the search term that you put in may limit you to like poor examples. I think if you wrote in like fallacious ads as your search term and you simply narrow the search to things that you know have fallacies, then as long as it doesn't say, hey, this is the fallacy in it, you can make your determination about which one it is by looking at the examples that are returned in your Google search. Sorry. As an alternative to that though, it's always, I think, a good thing to try and look at like full page glossy ads in like fashion magazines. So if you had like Elle, Cosmopolitan, or anything like that, if you would be willing to get one, or if you had access to one, taking pics of ads that are found in those kind of things, there's often a lot of fallacies. And so when you have like a book, like a magazine is, and it's got like 100 ads in it, that gives you a set of things that you can use as like a core material to refer to. So I think if you had like a couple magazines that would help you, feel free to use everything online too. TV commercials, commercials that are rebroadcasted onto YouTube, anything where there's an attempt to persuade, where you think the attempt to persuade contains a fallacy, then just mark it off, identify it, and label it as such, and put it into your submission. Anyway, though, sorry, dry throat. Let me get this. So just making sure you don't forget that. Your third homework, it's worth 100 points, so you definitely want to turn it in. It's due. Good to see you, Matthias and Matt and everybody else, Stephen. Make sure to just turn it in anytime before the end of the day, Sunday. So you'll just email that to me, attach the file, and then you'll be good to go for homework 3. The next thing that's coming up after that is our last quiz. We have a third quiz, and that's going to be a week from today. That third quiz is going to deal with the chapters that we'll discuss today and on Tuesday. So we're going to have 2 meetings on chapter 12, which is all about science. We'll do part 1 today, part 2 on Tuesday, and then Thursday, a week from now, that's when you'll have your quiz on the chapter 12 science material. After that, we're going to have 1 more homework assignment and the final. And the last homework assignment, homework 4, I'm going to slightly edit the due date. Originally, it was listed in the syllabus as due date of Tuesday the 18th. And I'm just going to slide that over to Thursday the 20th. We'll talk a little bit more about that homework assignment after this weekend, but I don't want to give you too much information right now just because I want you to be focused on the current homework assignment. But we'll talk about this on Tuesday, and then Tuesday will be what? The May 4th. And then you'll still have 16 days to complete it from there because it'll be due Thursday the 20th. And then, of course, the last thing is the final, which is on the last day of class on Thursday the 27th. So looking forward to the upcoming dates. Key dates for you are make sure to turn in homework 3 this weekend. Make sure that you're ready to take this quiz next Thursday. Then the 4th and final homework is going to be Thursday the 20th. And then the final exam will be Thursday the 27th. And we'll be given a study guide and we'll have review sessions the prior week leading up to the final. So that'll be the upcoming schedule of the remaining part of the class. Just sort of touching base with the schedule and dates at the beginning of our meeting today to kind of make sure we're clear since we're getting closer to the end. And it's important for you to try and maintain your focus and consistency through to the end. That's something that you always see as a professor. Classes sometimes will start off with people with a lot of energy and dedication to the topic, but then we'll sometimes taper off at the end. But I want you guys to try your hardest to sprint to the finish, don't limp to the finish, and just stay focused and dedicated because right now is actually when a lot of the very important assignments will happen. And you want to make sure to secure your best grade that you can. So anyway, just starting with that. Now, aside from that, we're going to start talking today about chapter 12. So I'm going to create the header, chapter 12, and that's all about science. So science is going to be our focus today and on Tuesday next week, and the chapter 12 test or quiz, that's going to be next Thursday. Before I launch into this set of notes on chapter 12, I want to just say something that's kind of random, but I thought, why not while I'm with my students tell you this. So over this weekend, can you believe it, on Sunday, somebody broke into my car. Man, come on. Someone literally did that, though. Someone broke into my car. It was parked in its designated parking spot in an underground parking garage. But still somehow somebody found a way to get in there. You have to have a gate key to get in. So I think just some person waited until the gate opened and then they were able to go in. So they broke out the driver's side rear window. This is my BMW. And I think the reason that they did that was because I had a nice guitar inside. So it was inside its hard shell case, and they just took the guitar out from the broken window. So it's like an American Telecaster Fender guitar, like $1,500 guitar. So I mean, that was too bad, right? But it didn't bother me too much, except for the hassle of having to deal with the insurance and stuff. But you know, I have insurance for homeowner and for auto, so that covered the theft and the vandalism of the window almost completely. $1,320 for the guitar. That's what the negotiated settlement was. So it's a slight depreciation in the full replacement value, which would be like $1,500. The thing that costing me more money is actually the window, because I have to pay a deductible for the replacement of the window. Most of the work and parts are paid for by insurance, but I have to pay the first like $500 deductible. So anyway, word to the wise, guys. When you have valuables, probably you know this, everyone says this. I guess I'm just the person that had to learn the hard lesson. But you know, if you have valuables, remove them from the car, even when you think you're parked in a secure place. That was what got me, because I knew that I was parked in my own underground parking garage from the housing area where I live. And since it's gated and stuff and you need a clicker, I thought that would be sufficient. But, you know, yeah, I left the guitar in there. And now, sorry. And now I got to replace it. But it's no big deal. just a little episode from real life to kind of give you guys the flavor of how my weekend was. It was like late at night on Sunday. So my neighbor actually was going to like drive off somewhere, and he called me because we have each other's number, and he's like, "Hey, Richard, come down here. I see someone broke out your car window." So I was like, wow. I filed a police report, got on the phone with insurance. So it's all pretty much settled. I'm just waiting for the car shop to finish with my window. But yeah, guys, take care of your possessions and valuables. Things can get stolen. And so I guess maybe it happened to me, and then it won't have to happen to you if you follow my guidance. So anyway, though, back to the real thing. Chapter 12, science. At the beginning of a lot of our different chapters in the book, there's discussion of some kind of like real world examples to bring you into the interest on the topic. And so at the beginning of chapter 12, they talk a little bit about the situation of global warming, important issue. So let's just briefly discuss that. Global warming is an increasingly major problem on the planet Earth because with human industrial processes that emit certain types of carbon emissions, this results in the trapping of heat in the planet's atmosphere because carbon emissions create like a greenhouse effect. They call these greenhouse gases because they kind of cause heat to accumulate in the Earth's atmosphere. So through our industrial processes, energy production, and energy use, we emit a lot of these carbon emissions into the sky and into the atmosphere. It causes heat to be trapped, and over time that produces a kind of warming phenomenon. Because of that, increasing greenhouse gas and accumulating global temperature, we're seeing global temperatures increase slowly over like the last 150 years. And what it's causing to happen is melting of Arctic sea ice. So like the ice shelf up in the polar ice caps is starting to melt away and erode a little bit because of the increased global temperatures. And that's causing sea levels to rise. Now, sea levels, because of this global warming phenomenon, have increased by at least 7 inches over the last 100 years. And according to certain models and estimates, even conservative models indicate that if we don't somehow get this problem under control or mitigate it, then we could see as much as another foot of sea level increase before we get to the next century at the turn of 2100. In recent decades, this heating trend has actually accelerated and sped up. If you were to look at like a graph that shows global temperatures since we started keeping these data back in like the 1850s, you'd see that the hottest 11 years since data has been started accumulated back in 1850, over the 170-year span there, the hottest 11 years have all happened since the year 2000, with the record-breaking heat years all occurring from 2010 to 2021 right now. So we're actually right now in the midst of an increasing heating trend on the planet Earth, and it's something to worry about because if we couldn't control it, and if sea levels increased at the rate projected without mitigation, then we could expect to have whole coastal areas significantly compromised by rising sea levels. And what college it is, Costa Mesa, we're all on the coast. We're over here on the West Coast. So it's a serious concern whether or not we're going to be able to maintain our status quo if the sea levels increase that much. So anyway, as critical thinkers, among the other things that we have to be good at, we want to be able to interpret and evaluate information from scientific community. We want to be able to evaluate scientific information that we see reported in the media, that we see in scientific journals, and that we hear in academic settings as well. So we'll focus on science throughout this meeting and Tuesday. We'll learn a little bit about the early history of science in the West. We'll identify what are some of the core basic assumptions of science. We'll talk about the scientific method. And we'll, at the end, talk a little bit about the difference between real science and what is sometimes called pseudoscience, fake science, or junk science. Okay, so what better way to start than with a clear definition of science itself? We also did that kind of at the beginning of chapter 3 and 4. 3 was all about language, so we defined what's language, system of communication that involves symbols. We started the chapter on knowledge. We defined knowledge. It's a belief that's both true and justified. So then what's science? Okay, well, let's say it this way. Science is just basically reasoning from observable facts to testable explanations for the facts. Science. Reasoning from observable facts to testable explanations for them. So science is a process of using reason, and what starts the process is observing just events and facts in the world, but eventually we try to provide some kind of testable explanation for the facts that we see. Okay, so imagine yourself a person living in a primitive, ancient time in human history. Way back there with, like, the Cro-Magnon man and stuff. If back then, like, a volcano had erupted, he would be able to observe this fact. Oh, something's shooting out a bunch of hot red stuff from a mountain. But that point in history, people didn't understand why. They didn't have an explanation. Why is it happening? So they would have just been kind of baffled. Wow, something's happening. I have no idea why. Or say a solar eclipse happened. All of a sudden, the sun is blocked out during a time when it just was out and it should be daylight. They would look up there and be like, oh my goodness, what's happening with the sun? They would see it happening, but they would not be able to explain why it's happening. Or lightning. Lightning is happening in the local environment. And primitive people see it. They're transfixed by it. They're mesmerized by it, but they have no idea what lightning is or why it happens. So what's science all about? Science is the business of trying to give precise physical explanations for what causes things to happen. So the scientist who sees a volcano is trying to figure out why does that happen. And eventually we get an explanation that we can't even test. There's like molten magma inside the Earth's surface. Various tectonic forces cause it periodically to eject material up into the air. What's lightning? A scientist can explain. A scientist will tell you lightning is just a discharge of electrons in the Earth's atmosphere caused by ionized water vapor. And so what is photosynthesis? How do these plants convert? Suction work, when you get into the actual details of like fertilization and conception, stages of pregnancy. Whatever questions you might have about things in reality, how they work, what's the cause and effect relationship between things, science is where you would turn to get yourself that explanation. So science wants to not just observe facts, but to eventually be able to explain what causes these observed facts, and to be able to create explanations that are capable of being tested for their accuracy. So the scientist doesn't just say, hey, I have a wild guess, here's how I think it works. They provide a hypothesis, which is then tested to see whether it's confirmable or not. And so science tries to give us answers as to why things happen and why they work. And that's important because that's changed and improved the human quality of life so much over the centuries. When you don't have science, you don't have technology. Because if you don't know how anything works, then you don't know how to manipulate the raw materials of the world to produce things that are good for you. So only a scientist can tell you why it is that we are able to use fuel that are fossil fuels to power internal combustion engines and transport ourselves around. So this computer that you're using right now, this is the result of scientific discovery and the technological innovations that have to do with chipsets, computing, electricity, and all the rest. So science has greatly enhanced the quality of life that people have. A pre-scientific era where people just have crude tools and no real knowledge about why things are happening is definitely impoverished by comparison to the modern status quo that we live in today. So we owe a lot of gratitude to the field of science. If there's anything that you want to know about in this world that you don't know about right now, science would be the best place for you to go to seek that information. So, like, how do clouds form? What is photosynthesis? What is the planetary orbits? How does gravity work? What is inertia, entropy? What are the laws of thermodynamics? If there's anything that you want to know about how it works or why, science is the best place for you to find the most cutting-edge, current-day answer to those questions. So it's important, and it's a huge source of knowledge and insight that benefits mankind. Now, what about the history of science? There's some important figures in the early history of Western science that are mentioned in the book, and so I'm going to point them out to you guys too. One of these individuals is Nicholas Copernicus. Okay, so Copernicus lived from 1473 to 1543. And he was a Polish astronomer, and he had an important discovery, which is sometimes considered like revolutionary for science, that in some views, it kind of set off the scientific revolution that led to the more modern time period that we're living in now. But what he did was, so he's a Polish astronomer. who discovered the heliocentric model of the solar system. Which replaced geocentrism. Polish astronomer discovered the heliocentric model of the solar system, which replaced geocentrism. Okay, so now, question for any of you guys. Maybe this is already familiar to you, but if it's not, I bet you your own just common sense and reason can infer what the discovery was. So what do you think it means that he discovered the heliocentric model of the solar system? What does that mean if you were to guess? Let me hear it from you. Let's see what you think. Discovering heliocentrism, what could that be? What discovery is this? It's the discovery that what? Heliocentrism, the heliocentric model of the solar system. What is that? Any thoughts? Let's see, take a guess. Because before him, okay, that's very good, Oliver, yes. So, the planets orbit the sun. The sun is at the middle. That's heliocentrism. Helio meaning sun, centric meaning at the center. So, the sun-centered model of the solar system, according to which the sun is at the base model, or is at, sorry, at the center, and we all and the other planets rotate around it in an orbit. Prior to that, geocentrism was the dominant belief, that the Earth was at the center. Now, why was it so important for people to have believed that the Earth was at the center of everything? Well, it was actually out of deference to the church. See, prior to around the 17th century, 1600s, the church was considered the dominant institution for discovering all truth and knowledge in the West. So in the early Christian era up through the medieval period, if you wanted to learn about anything, your education would not have been secular like it is in our country in this modern time. You know, we have a separation of church and state, so you can go to church on Sunday and learn religious lessons, or you can go to school, but unless this is like a private school, it's like a religious, you know, academy or something, your instruction and education is not going to presuppose any religious belief. But back then, before the modern era, before the scientific age and the, you know, age of reason, prior to the Renaissance, the church was the eminent institution. So anything that deviated from or conflicted with religious orthodoxy would have been regarded as impious, heretical, and not to be said out loud. So when Copernicus used newly discovered telescopes, like more powerful telescopes were coming into use, and he was able to use them to observe the motions of the celestial bodies. And he was, by means of observation, able to determine that no, the Earth's not in the middle, the sun is. Why did the church think it was so important for the Earth to be at the center? Because according to Orthodox belief at that time, God, if God created the universe for this, with mankind in his image, then they thought God would have wanted us to occupy a privileged position. We should be right in the middle, and literally everything should revolve around the planet Earth and humanity, if after all we are the whole reason for the whole universe to be created by God. So thinking that the Earth was not at the center would have been considered deeply unorthodox and contrary to their religious beliefs. But anyway, Copernicus did discover that. And also there was Galileo, another important figure who, in tandem with Copernicus, was also, he wrote Novus Organum. I forget the name of his book, but Galileo wrote a very important book where he was also using newly invented telescopes. And his published work was saying the same, that the Earth is not at the middle, but rather the sun is. In Galileo's case, he was actually persecuted by the church for saying this, and they forced him to publicly recant his testimony, meaning that they said to him, look, Galileo, we're going to execute you straight up if you keep saying this stuff that's getting people to no longer believe in God or to no longer accept like traditional views. So we want you to go out in public and say, I don't know what I was thinking, just kidding, I didn't mean it. The Earth is at the center, not the sun, whatever. even though he was in his 70s at that time, and he was like half blind from looking at the sun too long in telescopes, he was threatened with execution, and he was forced to recant his testimony. Anyway, though, Copernicus and Galileo, in the centuries that have passed since then, it's undisputed, and everybody all agrees that yes, the sun's at the center. We have much more powerful tools to observe with today that can definitively make this conclusively proven. And in fact, the church has since apologized to Galileo and the descendants of Galileo for persecuting him back then. But it's an important and interesting thing to think about, guys, something that you all take for granted, that the sun is at the center of our local solar system. Can you imagine living in a world where just saying that, because you've observed it through telescopes, etc., just saying that could have put you in hot water with the authorities and maybe even led to your execution and death. So in a way, we have a big debt of gratitude to thank for these early pioneers of science, because after the Copernican revolution, which some people call it, this revolutionary discovery that no, we're not in the middle, many people think that set off the scientific revolution that followed in the centuries afterwards, because it opened the door to the thought that through actual empirical observation and investigation, we can discover facts about reality that run contrary to religious doctrine. Opening the door to that possible idea that secular and scientific knowledge could gain its own footing caused it to really start to expand and rapidly advance. So scientific knowledge starts to really advance and take big strides in the 1600s and so on right after this. That's when we started to develop calculus, Newton's laws, the Cartesian coordinates of geometry. We started learning about Kepler, the planets move in smooth elliptical orbits around a central point. We started to also know about anatomy, and that the fundamental unit of biological matter is the cell. So all kinds of new important scientific discovery starts to take place in the era just after the Renaissance and after the discoveries of Copernicus and Galileo. So many people think of him as like kind of the father of Western science because of this revolutionary changed understanding of our position in the cosmos. And that's what it says here in the book. I'll read a little about it. The book says, prior to the 17th century, the teachings of Christianity, and in particular those of the Catholic Church, were regarded as the final source of all truth in the West. Nicholas Copernicus, a Polish astronomer, launched the scientific revolution with his assertion that the sun, not the earth, is the center of the solar system. Now, another important figure in the early history of science, and let me put him here, that's mentioned also in the book, is Sir Francis Bacon. Okay, so Sir Francis Bacon was British, and I guess you could tell by his title, having been knighted in the British Kingdom. But he lived from 1561 until 1626. And he's just a British statesman. He was at one time, I think, the Attorney General, but he wrote a book called Novum Organum in 1620. And what it included is like the first detailed description of the steps in the scientific method. So a lot of people give him plenty of credit for basically establishing the steps in the scientific method. So that's what he did, formulated the steps in the scientific method. Okay, now we're going to talk more specifically about all the steps of the scientific method in the second part of this lecture on Tuesday. But for now, anyway, I'm sure many of you guys have studied it at least at some level. It's usually a primary lesson in introductory science courses that you might have taken in elementary schools or even, high school and so on, middle school. But sometimes people divide up the number of steps slightly differently. Our own book is going to list 5 precise steps. But in general, in most teachings of the subject, there's a big 3. There's observation of some event in the world. That's the first step. Then you try to create a hypothesis that explains why it happened. And then you have to perform an experiment that will test the hypothesis to see if it's the correct explanation. So observation, hypothesis, and experiment. That's the overall core of the scientific method. And that procedure was first delineated in his book from 1620 called Ovum. Let me make sure I'm saying it correctly. Novum Organum. It's in Latin anyway. So yeah, we owe a big debt of gratitude then to Bacon, Copernicus, Galileo, and these other early pioneers of Western science for delivering us a changed world that's certainly much better for all of us today. So every medicine, every technology, every form of telecommunication, transportation, your microwave, your refrigerator, you know, this watch that I'm wearing, this computer that we're using, it's all because of the products of scientific inquiry and analysis. We have to first know how electricity works before we can build a conductor or a chipset. We have to first know what the electromagnetic spectrum is before we can harness a certain wavelength of it to control microwaves and to cook your food in the microwave. So scientific discovery leads to technology. It leads to best practices. It leads to all the things that make our lives better and more suitable for human civilization. Now, of course, sometimes scientific discoveries undermine our standing. Like, you could argue that all of the fossil fuels that we've created to help us transport ourselves around are starting to damage the planet. You could argue that the development of nuclear weapons, where we can even split an atom and release tremendous amounts of energy, could be a force for the destruction of all life on Earth if there was a nuclear holocaust. So I guess sometimes our scientific technologies make us worry that we might misapply them. But I still believe you'd probably rather be alive today with this computer that you're using right now than to be working on a farm and worrying about getting polio or typhoid or something 300 years ago. But anyway, science. It's really led to a modern era that I think most of us appreciate living in. But what are some of the fundamental assumptions behind science? That's the next thing to talk about. And the book lists a couple of them, so I'll go over them. Fundamental assumptions behind science. What are some of those? So things that science basically has to assume in order for the practice to even exist. Let us know what those are. So assumptions behind science. Okay, so one of the first assumptions mentioned is one that it's a concept that we've talked about at a different point in our class earlier, and it's the concept of empiricism. So it's coming back yet again. Empiricism. One main assumption of science is empiricism. And let me ask you to think back, maybe in your memory or notes, whatever. What is empiricism? It's the belief that most of our knowledge comes from somewhere, but where? And this is a basic assumption of science too. What's the view of empiricism? Someone tell me in the chat. Let me just check in with you for a minute here. Take a drink of water. What do you think it is? I think you know. It'll take a moment to remember perhaps, but you'll know. So empiricism is what? Don't tell me you already forgot. I just taught you this, a couple weeks ago, so you need to know it forever. I should be able to walk up to you in 20 years and be like, yo, what's empiricism? And you're like, point blank. It's the belief that most da-da-da-da. What is it? The awkward silence does not bother me. We could do this all day, but you have to say something eventually. Otherwise, we're just going to keep looking at the screen. So what is empiricism? All that we know comes from our senses. Exactly. There you go, Philip. What's the question mark all about? I think if you know it, you know it. That's what it is. So most human knowledge comes from the 5 senses and observation. Okay, so there you go. Rest of you guys, you don't remember that? What is it? Empiricism. It's the belief that most human knowledge comes from the 5 senses and observation. It's contrasted with rationalism, which is a different view about where most knowledge comes from, which says that most human knowledge comes from pure abstract thought and reason. But anyway, Empiricism prioritizes the five senses and observation as the main source of human knowledge. And that is a basic assumption of science, because science always begins with just an observation of facts in the world, and then that becomes the stuff that we have to try and provide an explanation for. So if we didn't think that observation, hypothesis, and testing could lead us to knowledge, then science would have no ability to really inform us about anything. Since science is essentially observation-based, the assumption has to be held by science that that can lead us to the knowledge that we're trying to get to. If we didn't think we could get knowledge through observation, then science would be shut down right off the bat, because it's all primarily based on what you can observe in the world and what you can then theoretically analyze about those things, what you can prove about them, and what causes them. So science begins with observation of facts. We then try to create hypotheses that explain the reasons that these facts happen. Then we try to test those hypotheses. But it all starts with observation. So a core assumption of science is that's going to lead us to the truth, that's going to lead us to knowledge. So one major assumption of science is this. A second major assumption of science is the idea of objectivity. So let me put this here and we'll discuss. Okay, objectivity. So the idea of objectivity is the belief that we can learn about the universe as it really is, and with no bias. So that we can learn about things not just as they appear to be, not just how they seem to be, but how they really objectively are. And that we can get to that objective truth with no bias or skewed perspective, like shaping our conclusions. So this is the belief that we can learn about the universe as it really is, not just as it seems to be, but as it really is. And with no bias. So let me make some comments here about objectivity. The concept of objectivity is oftentimes contrasted against subjectivity. And I believe that some of you guys maybe have like a generic idea, at least some kind of understanding of the difference between an objective and a subjective statement. So let me throw this out there at you and just give me what you think would be your common sense answer. If I say vanilla is the best ice cream, do you think that that is an objective or a subjective sentence or statement? Saying that vanilla is the best ice cream, is that objective or is it subjective? You got two options. Which one do you think? So, vanilla is the best ice cream. Is that an objective or a subjective statement? Okay, very good, Lan. Yes, and also Matthias. It's subjective. Can I ask a follow-up question, guys? You're saying subjective. You're correct. Can you tell me why you think that? Like, what would be the basic reason behind the answer? Why do you say that that is subjective? What does that mean to you to say it's subjective? To say that vanilla is the best ice cream is subjective? Yes, it is. Why? What does it mean to be subjective? What does it mean that that is subjective? Just asking that little follow-up question. So you got the first thing right. Yes, that's subjective. It is not an objective statement that vanilla is the best ice cream. It's subjective, meaning what? Okay, good, Lan, because it's based on my own opinion or personal preference. If I think that vanilla is the best ice cream, that may be my view. And in fact, it kind of is, because to me, this is just my opinion, I think it works really well with toppings and it's very neutral, so it's a great kind of go-to. It goes well with pie and other things. But anyway, it's an opinion, isn't it? It's something that's, people can have different opinions. Take another person who says chocolate's the best ice cream. There's no objective fact here, so I cannot say, look, objectively it's vanilla, or no, objectively it's chocolate. It's just subjective. It's relative to the individual's personal position, perspective, or point of view, right? Now, what about this, though? If I tell you that the Earth is the third planet from the sun, is this objective or is it subjective? Is that just my feeling and my personal opinion, or is that an objective fact? That the Earth is the third planet from the sun. Just a new question, a different example. But let's see if you're tracking me here. That's objective, correct, Lan, and meaning this, it doesn't matter how I feel. I might like it, I might not like it, but it's just the case that the Earth is objectively the third planet from the sun, meaning that that's an objective fact. It's not like my personal view. It's not like my own slanted, skewed, biased opinion on things. It's an objective fact. Now, going back to this, science assumes that there is an objective world. This world that you're in, it's not made up by your mind. It was here way before you got here. Sorry to say, it's going to be here way after you're gone. The world is an objective place. It's not a subjective domain that's created by your thoughts and feelings. There's a real external world that objectively exists. At least science assumes that. And if there is an objective world, there's got to be objective facts about it that we can learn about and that we can get to the truth with no bias. So science assumes that when we get to like a scientifically correct conclusion, that we're not just playing games with our feelings, talking about, well, this is my opinion and how I think, that we're actually able to discover objective truths through systematic observation, experiment, and testing. Now, you say, once all the words are well defined, the truth of the statement is obvious. Is this why you say it's objective? Well, I don't know. I mean, it's not obvious until we actually have the ability to examine the celestial orbit of the objects, right? So once we can do that, we can determine how many of them there are, what distance away they are from like the central point of the sun. But it's not so much that it be obvious, it's just something that it does not depend on an individual's particular point of view. The Earth would still be the third planet from the sun, even if nobody agreed with it. Yeah, you say it can be verified. Sure, it can be verified, and therefore it's something that can be proven as well, correct. The moon would still be orbiting the planet Earth, even if a person didn't like that or if they didn't like the concept of it. So science assumes that we are able to discover what's objectively true and not just talk about what we think is true or how we feel today or what our personal perspective is. I don't know if I put it a better way. I like your commentary too there, Matthias. Just kind of going back and forth with you a little bit. So anyway, yeah. If science could not discover the objective truth, what would be the point? If at the end of the day a scientific theory was just one person's opinion and if there's other opinions and no one knows the difference between which one's true or false, then it would just be another guessing game where we're not really getting to the truth. But science assumes there is truth. There's objective truth. We can find it as long as we use reason and the other tools, you know, that we have as human beings. So a major assumption of science. Let me read here in the book what it says. It says, a related assumption underlying modern science is objectivity. The belief that we can observe and study the physical world out there as an object outside of us with no bias on the part of the scientist or observer. Because the universe is objective and independent of the mind, the presumption is that systematic observation will lead to agreement among scientists. Okay, so we got to believe there's a real world out there. I mean, sorry, Descartes. I know we talked about Descartes earlier in the semester, who says, how do you know? Maybe the whole world's a dream. Maybe it's a hologram, some kind of simulation that you're in. Science, anyway, does assume that there's a real objective world and that we can discover it as it happens to actually be, not just as it appears to be to us. Okay. Cool. So hopefully that makes decent sense. Now let's go to the next assumption that science has. Another major basic assumption of science is what sometimes is called materialism. And that's what the book uses as the word, materialism. So materialism means basically this. But before I write the definition, let me make one clear point. The word materialism has another meaning that's unrelated to the scientific meaning. And I want us to make sure not to confuse the two, because this other separate unscientific meaning is not the point that we're talking about here in this class, in this chapter. Remember, like with equivocation, right? A single word can have more than one meaning. And so we could have two different understandings of materialism. So one meaning of it, the more, I think, common knowledge meaning of it, you call a person materialistic sometimes when you think, oh, they're just obsessed with possessions and material things and the way they look and maybe money. But no, that type of materialism in that social sense, that's not what it means in this context. So please set that aside if you can. Materialism in the scientific sense means the following. It's the belief that everything in the whole universe is just made out of physical matter. Okay, so it is the belief that everything in the universe is made out of, like is built out of, is composed out of physical matter, including even, and this is important, including us, and even our consciousness. It's all made out of matter. So says materialism. Okay, so it's the belief that everything in the universe is made out of physical matter, and that even includes us and our consciousness. Okay, so let's talk then about physical matter. Physical matter is stuff that takes up space, and when you think about material physical matter, there's a word that is sometimes used to refer to like the smallest little part of physical matter. Maybe someone here will tell me that. So who thinks they can say what the common word is for the tiniest little minute particle of matter? What do you think they call that? So you break matter down, 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 further and further. And when you get to the smallest thing, they commonly refer to it with the word what? What are those little particles or bits that make all these things? Atoms. Very good. Yeah, the atom. Now, it's true that in modern physics, we sometimes have heard of subatomic particles, like there's quarks and stuff. But if you go back in history anyway, the long-standing term that was first used in ancient Greece thousands of years ago for the tiniest piece of material substance was atom. Atom actually in Greek means not cuttable. Prefix a means not, and tome was like a part of a verb that had to do with cutting. So atoms are supposed to be uncuttable things, meaning that they're so small that they're the primary unit and you can no longer break them down further. Anyway, materialism, or this view here, it says that every single thing in the whole universe is just made out of that matter, which, again, I'll put it in parentheses, are atoms in the final analysis. So everything's made out of atoms, and this is important, even us in our consciousness. So if, according to materialism, a human being like you and I that is having thoughts, feelings, perceptions, hopes, dreams, fears, pleasures, pains, your mental life inside, memories, whatever, all of that is just the brain, and it's just the physical brain, which is itself a physical object made out of matter. So according to materialism, there could not be any such thing as like a disembodied consciousness, like a soul or a ghost or something that's totally detached from the physical body, but yet still exhibits consciousness. So according to materialism, even your consciousness that you have and you're experiencing right now as you listen to this lecture is just something physical. It's made out of the brain states and the neurological states of your brain. So, what is it to have the experience of watching a lecture? It's just for the physical brain to be in a particular neural configuration at that time. So according to physicalism, 100% of all things are physical and made out of matter. Not most things, not some things, but all things. So this table, this marker, me, you, we're different, but we have one thing in common. We're just a bunch of atoms bundled together a certain way to form the objects that you see. This marker is a bunch of atoms put together marker-wise. And me, this professor, this person, is a bunch of atoms put together human organism, Homo sapiens-wise. But in the end, we're just both physical things. So this would deny the idea of like an immortal soul or some kind of consciousness that could somehow escape the physical body and exist without it. As you guys know, ashes to ashes. So at some time in the future, the human body is just dust and there's a skeleton there, so there's no brain at all. According to materialism, I don't know if it's depressing to you or not, but according to materialism, that's it for your consciousness, because consciousness is based on the brain. And without a physical brain functioning, there's nowhere for the consciousness to be or to exist. But anyway, that's a view of science. Science assumes methodologically that everything's physical and material, even the mind, even thought, and consciousness. Some people reject this because obviously a lot of people think that consciousness is something spiritual, that it's something that does not have to do necessarily with the brain. But anyway, that's a scientific assumption. Not everyone holds this assumption. Some people will reject it. There are some, I think, decent arguments to the contrary, but it is a core assumption of science. Last thing I'll say is this. Materialism, the word, I think it's in some ways not ideal because it can confuse you into thinking of that other unassociated meaning of materialism, like a person that just likes possessions and things. So another synonymous label is physicalism. I prefer the term physicalism because it avoids the false equivocation that materialism can have when you think of it in its other meaning. But our book anyway has chosen the label materialism, so to remain consistent with the book, I'm using that same word. But when I teach the topic in other classes and stuff, I'll often use a, I think, more proper and precise term of physicalism. Okay, so yeah, that's another assumption of science. Let me read in the book, and you can hear it say this. The book says, with the doctrine known as materialism, empiricism goes a step further. Scientific materialists argue that everything in the universe is physical matter. Materialism in this sense has nothing to do with being obsessed with acquiring money, consumer goods, and other material things. So even the book notices that they have to disambiguate it. But then they say, according to scientific materialism, perceptions, thoughts, and emotions can all be reduced to descriptions of physical systems, such as brain waves or stimulus and response. There would be no need to bring into scientific descriptions extraneous non-mental concepts. Because of its materialistic roots, science has made little progress explaining how matter can become conscious. Okay, so another main assumption of science. And as always, guys, feel free to jump in, offer any kind of comments, thoughts, or questions that you may have. But I have a couple more assumptions of science to mention now, and then we'll be on to the next part of the notes. So after materialism, we so far talked about these assumptions. We said empiricism, objectivity, materialism. Let's go into the next, is predictability. Okay, so predictability. This is the belief or assumption that the universe overall is orderly and predictable, meaning that if we have established cause-effect relationships, that those are going to remain permanent, that they will be repeatable, and that they will hold forever. So here I'll write it down. The universe is orderly and predictable. So established cause-effect relations will be repeatable and will hold forever. Okay, so universe is orderly and predictable, meaning that if we have established cause-effect relations, those are going to be repeatable and they are going to hold forever, for all time. Let me try to explain that with a clear, I hope, example. Okay, so look here, I'm holding this marker, as you can see. I'm holding the marker and I'm holding it, you know, at this height above the table. It's in my grasp. Well, I'm telling you this. In a moment, I'm going to release the marker from my grasp. I'm going to let it go. And I just have what I hope is a simple little question. Can you predict, can you give me a prediction what would happen if I let this marker go? I haven't done it yet, so it's time to predict. We'll see what you think. Holding the marker right here, and I will open my hand and just let it go. So what do you think would happen if I did that? I'm asking your prediction, basically. If I let this marker go right now, what do you think would happen? I don't know. What do you guess? I hope it's not a wild guess. Okay, then you're saying, Remy, that it would drop. I'm sure any number of you would have thought the same thing, right? I mean, that's pretty obvious, or so it seems. I'm holding the marker. I'm telling you I will release it, and you say that it's going to fall. I'm going to hold you in suspense for a little while before I do that, but I have some follow-up questions, okay? So bear with me. I know they're very weird questions, but try your best. You say it's going to fall, yeah? Why? Why do you think that's going to happen? What reason do you have to think that it's going to fall? Because I haven't done it yet. So what? You could tell the future? How do you know that's going to happen? Or what's your reason? I heard your prediction. Okay, got it. You think it will fall. Why? Why do you think it's going to fall? Can you tell me any reason why you think so? Why? That's the question. Let me hear your answer. Okay, so I'm seeing your answers. Gravity, gravity, gravity. Okay. but I'm not done with you yet. You're saying it's going to fall because gravity, right? But what about this question? How do you know gravity is going to keep working? I mean, gravity always worked before, but what if it stops right now? What if gravity only applies until 3:15 p.m. on April 29th? And then after that, all bets are off and gravity's not working anymore. Why do you think gravity is going to work next time? Because we're talking about the future. We haven't been in the future yet. We've only experienced everything up till now. So how do you know for sure that gravity's not just going to take a day off or stop working right now? What makes you think that won't happen? Your answer was gravity. Can I ask you a follow-up question again? Why do you think gravity will continue to work? Why do you think that? I know you're almost stumped, but just think about it for a second. It's okay if it's like you almost can't say anything. You can even say that. But why do you think that gravity is going to keep working? Okay, so gravity is an answer you can give, but I'm coming at it from a different angle. Why do you think gravity will still work tomorrow or in 5 minutes? Why do you think so? Okay, Matthias, it's easier to live if we trust some things are universal, reliable, and consistent. That's an interesting response. You're saying, well, because it's like psychologically freaky to think that it might stop working. Okay, I understand that. That's kind of bound up with our feelings of like contentment and comfort, but in a metaphysical sense, why do you think it will keep working? I mean, outside of your psychology, and it would make you feel better to think so, why objectively do you think it will keep working? I know I'm being a little picky, but this is just trying to get you to think philosophically for a moment and to understand why this is an assumption. Okay, so look, let's do this. I kept you in suspense long enough. Let's see what happens. I'm about to release this marker. Ready? Who knows? Let's see if it falls. And when I asked you why, you said something like gravity, law of gravity. It's the law of like a massive surface of the Earth. It's an attractive force, so objects are going to fall to that surface from a freestanding height. And then I asked you, well, how do you know gravity will keep working? And it seems like pretty much everyone was not willing to say much. You're sort of like, I don't know, that's a weird question. But think about it, though. The reason that you believe it'll keep working is just because you assume that it will keep working. We can't really prove that it will, right? Because we would have to see what happens in the future. And by definition, the future's in the future. It hadn't happened yet. So we assume then that the law of gravity is not ever going to take a break, that it's not going to like stop working at some time. So we assume that gravity works all the way up till now, today and tomorrow, and forever into the future. But that last part, the assumption that gravity will keep functioning the same way throughout the whole future, this is an assumption that we must make, because until the future happens, I guess we can't get absolute guarantees. It's kind of like induction. You guys remember induction? With an inductive argument, you have a lot of premises that imply the conclusion is probably true, but they never absolutely guarantee it. So if I have an argument that says the marker fell yesterday, and it fell today, and it fell the day before that, and it fell a million times before that, so it's going to fall now, this is an inductive argument because we have to wait till you drop it to see what really happens. Science assumes that these laws are permanent and that they are stable. So not only does gravity work here and now, but it works everywhere and for all time. If we had another closed physical system on a different planet with a similar sort of mass, and there was a being on that planet that was able to drop a marker of the same size there, then according to your assumption, you should assume that that marker is going to fall there too, because we think that gravity doesn't just operate in some parts of the universe and not others. We also assume that it doesn't just operate for a limited time only and then stop. We think that this is permanent and for all time. But again, I hope you guys kind of get the idea now that this, as much as we assume it is true, it's not absolutely capable of proof. It's an assumption of something that will happen in the future. But it's probably a fair assumption with no contrary evidence to ever see even one counterexample to the functioning of gravity. I would say we're all well justified in holding that it will never change. But it is an assumption, and that's the reason that I gave you that example. I gave the case of gravity, but it could be anything else like entropy, thermodynamics, combustion, chemical properties of things that interact. When we understand how those cause-effect relationships work, we think we know it forever. Once you understand how photosynthesis works, you're like, well, I know how that works for all time because the process will never change. Or I know how gravity works for all time because once I learned about it today, it's a permanent feature of the universe. So that's yet another assumption of science. This universe is orderly and predictable enough that it has natural laws and cause-effect relationships that once you figure out what they are, you can count on it that they will always exist and that they will hold for the rest of time, even if we cannot say we absolutely are guaranteed. We have to make the assumption. So that's another assumption of science. And one more then, before we go to the next part of the notes. One final assumption mentioned in the book is what's called unity. So this is the assumption that there is an underlying unity to the universe, which means that such that everything can be explained according to a single set of scientific laws. Yeah, so unity. The assumption, the belief that there is an underlying unity to the universe. Such that everything can be explained according to a single set of scientific laws, scientific and natural laws. Okay, so there is a unity to the universe such that everything can be explained according to a single set of scientific laws. This is another assumption of science. So science assumes, anyway, that since we live in a physical universe and it's one universe, then it should operate according to one set of laws or rules. That there should not be different sets of laws that, say, govern the behavior of microscopic things versus macroscopic large things. And this is the really kind of like holy grail of science. This is the goal to be achieved that still to this day has not yet been fully achieved. The reason it hasn't yet been achieved is because as of today, we actually do have two different sets of laws and principles to describe the behavior of things on the large macro and the tiny micro scale. So for tiny little particles, we have quantum physics, and that's very predictive, and it does describe the behavior of tiny little quantum events. But for the larger scales of reality, the big picture, we have the electrodynamics of moving bodies and the theory of general and special relativity from Albert Einstein. But in fact, the theory of relativity and quantum theory have some contradictions at the margins between each other. And so scientists hope and assume and believe that someday we will be able to build a bridge between the two fields and unify them into one elegant set of consistent scientific laws. In fact, there's a term for this. The term in science is GUT, which is Grand Unified Theory. The Grand Unified Theory is like the ambition of science to eventually be able to achieve the mastery of one single comprehensive set of scientific principles that could explain everything. But as of today, we're still not there. We have quantum for the little stuff, relativity for the big stuff, and we're waiting for something that can kind of bridge the divide. But anyway, science assumes that, again, since there's one universe, why should there be different sets of natural laws? You'd think, anyway, according to just parsimony and common sense, that one system operates according to one set of principles. That's what it does say here in the book. Unity, associated with the belief in predictability, is the assumption that there is an underlying unity of the universe, or a unified dynamic structure that is present in all phenomena. These unified structures can be translated into scientific laws that are universally applicable. Indeed, Albert Einstein devoted considerable effort during his life to search for a grand unified theory, but to this date, we have not yet achieved the goal. Okay, so that's one other assumption behind science. Now, I want to talk to you guys for a moment about what are some limitations that science has. This is also discussed in the book. And so what are like certain limits, things that science kind of takes as a given but cannot necessarily prove, or limitations to what it can actually deliver us in terms of knowledge or insight. So what are some limits of science, limitations of science? Okay, so some of these limitations I thought were quite philosophical, and for that reason, it'll take a little discussion to fully unpack it all, but no big deal. The first one is this idea that science assumes the external world exists, which I know all of us assume, but so does science, and I guess that's something that you cannot absolutely prove. So science assumes the external world exists. Okay, so the external world. We talked before about Descartes, if you remember that. And Descartes says, hey, who knows if you're dreaming? Maybe everything you think is real is just a dream and you're in the middle of a big simulation right now. So all bets are off. Maybe none of this is real and it's just seeming like it is. But science assumes that's false. Science assumes that there is an external world, that you're perceiving it all the time in your everyday life. And obviously science has to assume this, because what would be the point of scientific investigation if what you were investigating was a simulation? That would be like if Mario in the Mario Brothers universe started trying to do scientific experiments to determine how the, I don't know, how the power plant or the Super Mario mushrooms work. He could not be learning anything real because his environment is not itself a real world. It's a simulated environment. So science assumes that we are in touch and in contact with the actual external world, that this is not all a dream, an illusion, or some type of weird hologram that you're in the middle of. Why is this a limitation? Well, I don't want you guys to like think too much of this. Obviously, we all assume that the external world exists, and it would only be like the most hardcore skeptic or solipsist that would say, hey, I don't know, maybe I am dreaming it all. Even though Descartes wrote that, even he himself at the end of his book says, no, actually there is an external world, and I think now I can prove it. But setting that to one side, there's no absolute method by which you can really prove the external world exists, because suppose that you were right now in the midst of an illusion or simulation. If it was a very good simulation, then what would it look like? Well, it would look exactly like the real experience. So suppose this is your real experience. A simulation, if you were in it, would be exactly identical to this. And so that's the reason you'd never be able to tell the difference between the two cases. So anyway, we just help ourselves to the assumption that the real world is out there and that it does exist and that it's externally real, not just created by your mind or some kind of other source of deception. And I think everyone is not really too much bothered by this assumption, but at the end of the day, it can't technically be proven. So one assumption of science, but I don't think it's one limitation of science, but I don't think it's one that bothers too many everyday people that much, and none of us either. Another limitation of science is this, and this is interesting. It's only able to study and discuss things that are observable. So science can only study things that are observable, and that might be a limitation if there's anything that's not observable. Okay, so science can only study that which is observable. Okay, so in science, one limitation is if something could not be observed, if it's outside the realm of either direct or indirect observation, then science wouldn't have anything to do with it, because science has to proceed from observable data. But that might be a limit, because if there's anything supernatural or if there's anything that's non-physical, then that would permanently be outside of scientific investigation and analysis. So say there was like a soul or like an afterlife or heaven or hell or God. Those things would not be physical things, right? Like your soul is not thought of as like a little tiny organ in your body. It's thought of as something that's totally disembodied, immaterial, having no shape, form, mass, or physical substance. So if there are such things as, you know, mysterious, supernatural, or spiritual entities, then because they would never be observable, science could never not know about them. On the other hand, a scientist is probably just going to be a skeptic and say, well, those things don't exist. That's why they are, quote unquote, not observable. But even in scientific practice, there are some things that are postulated by science that are not observable. Like, sorry, one example is this. Right now in this universe, physicists have noticed that all matter is rapidly expanding outwards from everything else. So it means that the concentration of matter is becoming gradually less dense. And actually the rate of expansion is accelerating. And that's not perfectly well understood why that's happening. You might have thought, okay, well, the Big Bang pushed all the matter out. But there are attractive forces like gravity that should cause some of these things to come back together and coalesce. So what's fueling this outward ejection of material in all different directions? Some people postulate the existence of what is called dark matter to explain the phenomenon of the universe's expansion. But dark matter, being dark, is postulated to be completely incapable of physical observation because it's, you know, it's not detectable by any mechanism that we could possibly invent. since it is dark. So if dark matter is remaining unobservable, then it will always be something very tricky and difficult for scientists to fully theoretically understand. Now, some things that used to be unobservable become observable through the introduction of new technologies, like the atom that we talked about. I mean, thousands of years ago, ancient Greek people coined the term atom for the least unit of matter. But for many, many centuries, this was just a theoretical postulate. It was posited to exist because it would explain a lot of things physically. But then we were finally, in the 20th and now 21st century, able to build actual electron microscopes so we could finally actually observe the particle that for so many centuries was simply considered to be a theoretical entity. So what's observable can change over time a little bit. But again, if something is considered to be permanently unobservable, then it would be outside the realm of science. And if you think such things as those exist, then that's perhaps a significant limit of science. And one last limitation, I'll just talk through this one. Some people critique the predictability assumption. There was a philosopher in the 1700s, a British philosopher named David Hume, and he believed when you assume that the natural laws will never change in the future, you're helping yourself to an assumption that you really can't guarantee. Because as I've said, all your experience is of the past up till the present. What happens in the future, you can predict, you can sort of induce that it's going to be similar as to the way the past was. But since we've learned about induction, you know that the inductive conclusion cannot be absolutely guaranteed, since it relies on the assessment that the way things have functioned is the way that they will continue to function. So we help ourselves to the predictability assumption in science and in a lot of everyday aspects of life, but it cannot be absolutely guaranteed either, and so maybe that's a further limitation. Okay, now, after all that, the next topic that the book goes into in chapter 12, and probably this will be the last thing we'll get to for today's meeting, are what are some different views that people have about the relationship of science and religion. And there's 4 different views that are mentioned in the book, so I'm going to try and put them here. 4 views about the relation of science and religion. Okay, so I'm sure a lot of you guys have heard that to many people, science and religion don't seem to necessarily go together. That although people oftentimes claim to have respect for both, that if you just look at what they each say, that it's fair to say that sometimes they don't necessarily agree. Like in religion, we have the idea of creationism, that God created us in His image, and that we're like this special, sort of crown jewel of creation because we're created in the image of God. Not that we, let's say, went through a gradual process of natural selection that led to the establishment of Homo sapiens from great apes. But then science says, no, the theory of evolution is the way that human beings emerged on this planet. And it took billions and billions of years of gradual change and specialization. So that's one case. Or we could talk about, in the Bible, it says that God created, in the Christian Bible, in the Old Testament, it says God created the universe in 7 days, and on the 7th day He rested. But science tells us that it took billions and billions of years for matter to coalesce into stars and then to form planets, and then much even longer than that for little single cellular life forms to specialize and diversify and to become reptilian, mammalian, and then what we are today at the tail end of that process. So what is it, 7 days or billions of years of evolution? Another apparent disagreement. There are some religious denominations which claim of the earth that it's only like 5,000 or 6,000 years old, and that seems to be contradicted by scientific, consensus that dinosaur fossils have been recovered, and carbon dating shows that they're millions and millions of years old. So anyway, guys, we could go on and on. Was there a biblical flood? Religion, some would say yes. Science would say no. Did Adam and Eve live in the Garden of Eden back at the dawn of human existence? According to the Old Testament Bible, yes. But again, as evolution would have it, no, there was never just 2 single specimens of human on the planet. So science and religion seem to not always agree. What to think about that? Well, there's different views. So one view is this. One attitude or perspective that some have is that science takes priority over religion when the 2 conflict. Okay, now, for some people, they will just say that if science and religion don't agree on something, if I'm looking at the difference between the creationism and evolution, or the Genesis story of creation versus the scientific cosmologists' much more kind of gradual and drawn out account. Well, if any such conflicts or disagreements exist, some people will say I'm going to go in favor of science. So I'm going to accept the scientific explanation, and I'm going to reject the religious one that conflicts with it. So for some people anyway, they're more fond of the scientific explanation, or they have more rational trust in it or whatever, and that's where they place their confidence. So to take priority over religion when the two conflict means that you grant the scientific explanation credibility and you reject the religious one. In the book, the word that they used was science trumps religion when the two conflict. And I could have used that same term, but I thought that, since our last president was named Trump, you might got confused, because Trump is itself, outside of the reference to that president, it's a verb. And if something trumps something else, then we say it takes priority over it, or it's given preference to the other thing. So if I say that, my family trumps work, that means that if I had to choose between family and work, I'm going to go in favor of my family because that's more important to me. But to avoid any false associations with his name, I just went with the more precise term. Science take priority over religion when the two conflict. That's one view, but it's not the only one. Some people are on the other side of this. So what's the opposite? It's just that religion takes priority over science when the two conflict. Okay, so obviously another option that some people anyway, will take is to say, no, I'm going with religion when the disagreements exist. I'm going to say somehow the scientific answer is wrong or misinformed or whatever the case may be. So some people are going to say, when I hear religion saying that God created us in his image and evolution says, science says something different, I just reject evolution and I hold the religious thesis instead. Or if it was about, the flood or Adam and Eve, and if that's contradicted by a scientific account of history, then they might say, well, I think the scientists must be getting something wrong because religion is true and righteous and it's vindicated by God. So, there's different people in this world. I'm just trying to show you the full range of options that are out there. Some people, in view of these conflicts, they side with science, and others will side with religion in the same cases. Now, there's two other possible options too, and I feel like the other two try to diffuse the appearance of conflict. And so these are like saying the conflicts are real, and I'm going to go with one or the other. But the other two try to kind of like either eliminate or change the assessment that there really even is a conflict. So the third view says that science and religion, they just deal with different topics. So they really can't conflict since they're not in the same lane. They're in separate lanes dealing with different information, different subject matter. So there's no room for them to really step on each other's toes. That's a third view. Science and religion deal with different topics, so they don't conflict. Different topics, so no conflict. That's a third idea or view. So to some people, science and religion, they have their own separate sphere of interest and concern. You could argue that when it comes to science, that's when you're trying to learn about the objective physical reality, and you're trying to learn how material processes and cause and effect relationships work in nature. But when you're looking at religion, you're instead now looking at a subjective spiritual reality, which is also about your moral life and what you think is good, bad, right, and wrong. So when you're turning to the spiritual and subjective and moral side of life, you're looking at religion. And when you're turning to the objective, physical, and cause-effect relationship side of life, you go to science. This is one way of trying to avoid the difficult question of what to do when the two things disagree. But I would say, and the book mentions it too, that it's a little hard in some cases to sustain this view only because science and religion, at least on the surface, do appear to talk about a lot of the same things. Like science has an account of the origin of man and the origins of the universe, and religion has one too, but they don't seem to agree. So how can we really eliminate at least the appearance of conflict between the two when they seem to speak about much the same material in some cases. How did man come about? What is the origin of the universe? What's the position of the planet Earth? I mean, at one time in history, science and religion had a serious disagreement about whether the sun or the Earth was at the middle of the cosmos. So how can we really always say they don't conflict? At least it might be hard to finesse that view and to hold it, but that's the third view. And a fourth view, interesting last one, is this, that science and religion are somehow compatible. Let me put that here and try to explain. Okay, so whereas this one was trying to say, hey, they're in their own different lanes, so there's no overstepping their boundaries. This one says, actually, they're saying the same thing. They only look like they disagree because maybe you're not interpreting the religious information correctly. So this is the view that people have when they try to, let's say, expand on or reinterpret biblical literalism to accommodate the findings of science. So let me see if you guys can follow up on this thought. Suppose someone holds this view, yeah? They think science and religion, if you just interpret them the right way, they will agree. Let me ask you about questions. So suppose, as we say in the Genesis Bible, it says God created the universe in 7 days, and on the seventh day he rested. But then you hear in science that it took billions and billions of years for stars, planets, and complex life forms on Earth to form. So now your question is this. How could you make those two things compatible with each other? The scientists claim that it's taken billions of years versus the theologians claim that it just took 7 days. You might be able to say, well, they're actually in agreement with one another because maybe in the Bible when it says that, it actually just meant what? Can anybody kind of complete my thought here? I'd love to see that. So somebody who's trying to reconcile and make consistent the biblical story of creation and the scientific account of how long it took. How do you think someone might try to modify or reinterpret the scriptures so that they fall into alignment with the scientists' conclusion? Maybe they could say that what? Just to see if you can formulate this comment for me. How can you reconcile those two loose ends? Science, billions of years, religion, 7 days. By maybe interpreting differently the meaning of what? Just waiting for your answer, and then I can complete this and wrap it up. Is the question coherent to you? I'm asking how could a person reinterpret or finesse the language of Scripture so that it does not disagree with the scientists' conclusion that it's taken billions of years, not 7 days, for this universe and human beings to form? They could simply try to reinterpret the meaning of what? Okay, there you go, Philip. You could say that, correct. A person might say, well, it says 7 days, but that's just a unit of time of arbitrary length. A day doesn't really need to be 24 hours of time as we would think. It could refer to some mysterious epic of time that's much, much longer. And so 7 days for God is like whatever, billions and billions of years for us. There you go. Conflict eliminated. They are compatible. Or maybe somebody hearing that evolution is different from creationism could say, well, I guess what it meant is that God created us by knowing in advance what the process of evolution would result in, that it would result in the human form of life. So we were created in his image, but he uses the processes of natural selection and evolution to get to the end result. So you can always try to find a way to bring together the two claims so that they don't really have any kind of conflict. But here's what I would say about that could be seen as a criticism. It is somewhat ad hoc, isn't it? It seems like the person is just kind of trying to cover up whatever inconsistencies there are with a new reinterpretation. And notice that these modified interpretations of the biblical literalism are never thought of before a scientific discovery. They're created ad hoc afterwards to somehow make it consistent once again with the scientists' results. So, like for example, if you shot just an arrow at the side of a barn and you had no aim, you just hit the barn anywhere, and then you walk up to wherever the arrow lands and you draw a bullseye around it, that doesn't mean you're an expert marksman because you hit the bullseye. You just drew the bullseye afterwards, wherever the arrow happened to land. And I sometimes think of this as a metaphor for how people try to reinterpret claims to bring them into alignment with new information that comes out only later. So the scientist discovers evolution, and now the theologian is willing to open up the space of interpretation to relax the literalism of the biblical doctrine that God created us in his image. So you could sort of look at it as these modifications to the scripture and the interpretation of them are only ever promoted once a scientific discovery puts pressure on them to change the interpretation. So is that intellectually dishonest? Some might think so. But anyway, that's, I think, probably a very popular view. To those that are religious but still have deep respect for science, many times they'll hold one of these two views so that they don't have to make a clear rejection of the scientific claims or consensus views. All right then, guys. Well, we've gone some decent way through chapter 12, but we have more to do. So when we come back on Tuesday, we'll finish it up, and we'll start with the scientific method. We'll talk then about what are some qualities of a good scientific hypothesis or theory, and then we'll talk about pseudoscience at the end just a little. And then again, next Thursday, a week from now, we'll have a quiz on chapter 12. So it'll be just on this material that we're talking about today and next time. But that's about it. We're running out of time, so let me know that everything's good. And if you guys are good with that, then we can close for now, and I'll see you after the weekend. But first, say goodbye. I don't like to ever hang up on people or stop a call or anything else without mutual recognition that it's done. So are we good to go? Just let me know. Okay, thanks, Philip. Thanks, Oliver. And thanks also to everybody else. Now, some students that are maybe only watching the lectures later as a recorded lecture, try to come to these live streams. There's really no substitute for getting the interaction and the back and forth, but do your best. At the same time, I do appreciate it when we get, as close to full attendance as possible. But for everybody that's here today, I always appreciate you showing up. So anyway then, have a good weekend. I'll be in touch if you need anything through email. And don't forget to turn in that homework to me by the end of Sunday. And from there, we'll meet up again on Tuesday. All right, have a good one, and see you soon.